Okay, my bad. All right, let's get started. Good morning, good afternoon, good evening, everyone. Welcome to workshop 5 of beginner track. In this workshop, we're going to be talking about k-nearest neighbors and intro to Python. So here's the link for the slides, and our attendance code today is going to be Coco. All right, let's get straight into KNN classification. So what is KNN? So KNN is kind of similar to logistic regression that we went over in the last 2 weeks, where we're trying to classify the new data point into either class A or class B. So the goal is to basically classify the new data point based on how its neighbors are classified. We're going to go into detail about how that works in just a moment. It is one of the simplest supervised ML algorithms. So that means we have to start with labeled data sets in order for this to work. And notice that the outputs are discrete, like I mentioned. All right, let's get into some of the intuition behind KNN. So let's suppose we're trying to classify a new image into either like a cat or a dog. So let's think about some feature differences between cats and dogs in general. So for example, cats might have sharper claws, shorter ears, and they meow, while dogs might have duller claws, longer ears, and they bark. So how we represent this graphically? So if we plot this into a scatter plot, it might look something like this, where cats have shorter ears and sharper claws. So most of the cats are going to be clustered in the closer to the top left corner, while dogs have longer ears and duller claws. So they'll be clustered closer to the bottom right-hand corner. So suppose we have an unknown animal, picture of an animal that we're trying to classify into either a cat or a dog. So how would we manage to do that? Anyone have any guesses whether this is a cat or a dog? Feel free to type it in chat. Just any kind of random guess is good, I guess. Cog. All right. Got some answers. I think most people are saying it's a cat. So is there a cat or a dog? So if we pick the 5 nearest neighbor to this new unknown animal, 4 of them are cats and 1 of them is a dog. So what we can tell from this is this new unknown animal is closer to the cats in features in terms of its features. So therefore it's reasonable for us to classify this to be a cat. So anyone have any questions about what we just went over? Like classifying the new unknown animal into. Okay, someone asked, how is the value of k determined? That's a great question, and we're gonna get into that in just a minute. All right, so we just went through an example of a KNN. So how does it actually work? So we start with a labeled data set, like for any supervised algorithm. And we basically classify new data points based on how their neighbors are classified. So for example, if we're trying to classify this yellow question mark here, we're looking at how its neighbors are classified. So if k is equals 3, we're gonna classify this as a green triangle. And k is basically a parameter that refers to the number of nearest neighbors to include the voting process. So when we're trying to classify this yellow question mark, so basically all its neighbors can cast a vote, and the class with the most votes. So this data point will be classified into the class that has the most votes. So for k equals 3, this will be classified as a green triangle because the green triangle has 2 votes and the red star has 1 vote. But if k is 7, then the red star has 4 votes and the green triangle has 3 votes. So this will be classified as red if k is equal to 7. All right, let's do a quick poll just to make sure that we're all on the same page. All right, and I just launched the poll. Let's see if there's any question. All right. Someone asked if, like, what happens if the votes are equal? So that's a great question, and that's the scenario that we're gonna try to avoid by choosing an odd value of k if there are 2 classes. If we're doing binary classification, so there's always a tiebreaker. And someone else asked, is a higher or lower value of k more accurate? So in general, for a low value of k, like you basically the result could be easily skewed by like an outlier, if that makes sense. If k equals 3, like if one of the data points is an outlier, then the result will be like messed up, I guess. But for a larger value of k, like it'll take more computing time in general. So, and if you pick k to be like total number of data points, then that's also problematic because like if you have more data point from one class than the other, then the new data point would always be classified as the class that has more data points if k is the total number of data points in your data set. All right, so most of you guys picked red, which is the correct answer for the poll. Someone else, one person picked blue, so I guess it's pretty intuitive why it's red, because the 3 closest neighbors to this green data point is 2 of them are red, so that's why red would be the classification that we give. So, all right. Let me close this up. Okay, so like some of you guys asked, like choosing the factor k is pretty important for KNN, just because KNN is based on feature similarity, and we're basically implicitly assuming that similar data points are close to each other in terms of features, so, and therefore they should be classified as like the same class, if that makes any sense. So choosing a right value of k is basically a process of parameter tuning and it's pretty important for like good accuracy. So like we went over in the previous slides, so if k is equal to 3, the question we classify a question mark as a triangle, but at k equals 7, we classify the question mark as a star. So which one is correct? So, all right, so if the problem of k equals 3, well, this is a pretty small data set to start with, but if one of these green triangles turns out to be an outlier, or like I guess maybe there's an error in terms of its measurements, then the results of this question mark will be messed up, if that makes any sense. But if we choose k equals 7, then it's less likely that this is going to happen. So in general, if we pick the k that is too low, the results can be easily skewed by outliers. And if we pick a k that is too high, is expensive to process computationally. I mean, for this like small data set, it doesn't really matter, but say if you choose K to be 100 or even 1,000, then it'll definitely slow down your algorithm like significantly. Well, maybe not, maybe 10,000, because I think 1,000 is not that much for computers these days. So a general of choosing the right value of K for a large data set is taking the square root of n, where n is the total number of data points in our data set. And we should also make our K odd in the case of a binary classification to avoid potential time the voting process. All right, so when is a good time to use can-n? So one of the conditions is when the data is noise-free relatively. So here's an example of a noisy data set. So here we're trying to classify whether people are underweight or normal. So this column, we have their weight in kilograms, and in the second column, we have their height in centimeters. So as you can see, there are a lot of classes that are, I guess, nonsense for this machine learning problem. So 140, 23, and Hello Kitty are not legitimate classes for this classification. So basically what that means is these data are kind of nonsense and our machine learning model cannot interpret them properly. So that's gonna mess up our can-n algorithm. So yeah, this is not ideal for can-n at all. Yeah, the second condition is the data set has to be relatively small because can-n is a lazy learner. So what that basically means is it doesn't learn a discriminative function from the training data set. So as you can probably remember from linear regression and logistic regression, we have to define a model, which is basically an equation which our ML model is trying to learn. And we're trying to find the set of weights and biases that minimizes our loss function. But for can-n, like we don't have a model, we don't use a loss function, and we don't use a gradient descent. We're basically just we're basically just classifying a new data point based on its neighbors. So that doesn't require any of the math, I suppose, that we went through for our previous workshops. So I guess the upside for that is this is more intuitive that way. Like you can easily understand how it works. But the downside is it's also like pretty slow, especially with because like you have to calculate which data points in your data set are closest to the new data point that we're trying to classify, and then you have to sort them. You have to sort the table in order to find like the K closest neighbors. So that takes a long time if you have like a data set of like 1 billion data points, which is quite common in industry. Actually, I think like trillions and quadrillions are more common in industries, but yeah. All right, does anyone have any questions about what we just went over? All right, I'm gonna launch this poll real quick. All right. Doesn't matter how close the points are to new data point. All right, do sum up more weight. Okay, that's a great question. So in order to avoid like I guess an alternative approach for can-n is to assign like a higher weight to data points that are closer. So, okay, I guess this will be easier to explain with an example. we'll get back to it after we're done with this poll, I guess. But that's a great question. All right, let's give it 10 more seconds. All right. So most of you guys picked 13, which is the correct answer, because the square root of 170 is closest to 13. I think some people picked either 12 or 14, but remember, like, we want our k to be an odd number to avoid potential tie breakers or ties in the voting process. All right, so someone asked how close to data points, does it matter how close the points are to a new data point? So as you can see from this example, like for k equals 3, this question mark is classified as a triangle. But for k equals 7, this is classified as a star. So if we assume like closer data points have more weight, because this is closer to, this is really close to these two triangles. So therefore, like these two triangles should have more weight on the outcome of this question mark. So if that's the case, like I think it's pretty likely that this question mark will be classified as a triangle, even where k equals 7, just because like these three stars should have a lower weight assigned to them in terms of determining the outcome of this question mark, just because they're pretty far. And yeah, that would potentially fix this dilemma that we're running into. And I guess like for what weight, you should probably like determine that experimentally. So like, I guess you can, the weight can like decrease like 1/r or 1/r squared. But you should probably determine that experimentally to see what works best for your model. All right. Let's take some more questions, because I think I've been going through the stuff kind of quickly. Also, feel free to unmute to ask questions or follow-ups. All right. It looks like we're good. So let's do a case study, I guess, to see how KNN works in practice. So consider like a data set with two variables, so namely height and weight. So weight is in kilograms and height is in centimeters. And for each data point, we classify them as either normal or underweight. All right, so on the basis of a given data point, so this new data point here with 57 kilos and 170 centimeters, we have to classify it as either normal or underweight using KNN. So to find the nearest neighbors, there are different ways to do this, but the most intuitive way is just to use the distance formula. So we're basically subtracting, finding the difference in weight and difference in height, and then we're squaring each of the quantities, adding them together and taking the square root. And so we'll basically calculate the Euclidean distance of the unknown data from all of the points in the data set. So we're basically calculating the distance for the first data here, first training example. So it's the first row, and then we're doing it for the second row here. And then we get about 13. And then we basically do it for all the data points, which is why this will take a while. If you have like a data set with like 1 billion data points. And then we also have to sort our data set based on its distance in order to find the data points that are closest. So here we have calculated the distance of all the unknown data points as listed in this last column from the data point that we wish to classify. And the total number of data points in this data set is 10, which is pretty small. And we'll use k equals 3 just because that's closest to the square root of 10 and it's odd. So we find that these 3 data points are closest to 57 kilos and 170 centimeters. And these are all classified as normal. So that's what we're going to give to our new class. All right. Any questions about our case study? Oh, how will you choose units for input data? Because if you scale the input data, should change how the distance is weighted between the different inputs. So that is a great question. So for those of you so just to recap your question, like if we choose meters as a unit for height, then the difference between 1.5 meters and 2 meters is 0.5, which is pretty big. But if we use kg for weight, I guess someone who weighs 60 kilograms and someone who weighs 60.5 kilograms are not that much different. So units does matter a lot. And I guess there's no like one, like, I guess, set of units that you have to use for this. So for height, I guess inches and feet are also reasonable units. And for weight, you can also use like pounds. So I guess in order for KNN to function, like work like reasonably well, you have to pick a set of units that, you know, like, I guess work well together. And you kind of have to determine that like experimentally. So I don't think there's like a theory where it says you have to use these like set of units for the problem. So I hope that answers your questions. Okay, someone asked, can you have many classes or is binary preferred? So I guess for this workshop, we're going over binary classification because I guess it is most intuitive. But yeah, in principle, you can have like many different classes. And the idea is like data points from the same class will cluster close to each other. So yeah, but like, I guess if you have like multiple classes, like say 3 classes, like the way you choose K is like kind of different because like you want to avoid like any potential ties. So you have to choose a K that is not divisible by 3 if you have 3 classes and so on and so forth. Does that answer your question? All right, I think. All right, cool. So let's recap how KNN works. So we start with a labeled data set along with a new data point or sample. We compute like the K that we should use. And then we select K entries from our data set that's closest to the new sample. And then we find the most common classification out of these K entries. And this is the classification that we give to the new sample. All right, so that's basically what we went over for KNN. I guess I can spend like a few minutes to take some more questions. Would the K also not have to be divisible by 2? Okay, I guess this is referring to binary classification, right? because like I guess the k value like depends on like how many like classes there are. So I guess for if you have like 3 classes, then the k can be divisible by 2 because, oh, actually I see what you're saying. I guess, yeah, that will be if k is not divisible by 2, then that will be preferred. But I guess it's if it's divisible by 2, it's also like not the worst if you have 3 classes. Yeah, okay, so Sudhanshu said it shouldn't be divisible by 3. Yeah, but like I guess if you choose like k equals 10 for if you have 3 classes, then I guess you can have 4, 4, and 2. So that will be like a tie between the 2 highest classes. Okay, wait. How do you settle a tie for multiple classes since 2 class could tie out 3? I guess you can do another voting process if let's say we have 3 classes and we choose k is 10. So class A has 4 votes, class B has 4 votes, and class C has 2 votes. Then we can redo the votes between the 2 highest class, but this time we choose a k that's odd to avoid any tiebreakers, if that makes any sense. Okay, with k and n are there times when axes like weight would matter more than another axis like height? Yes. Okay, like using distant formula would matter by the same amount. I guess the answer of this is it really depends on what you're trying to do with your problem. So I guess when we're trying to classify people into like for the normal or underweight, I guess it's really like up to the problem that you're doing. Like you can choose like a unit where I guess weight and height would matter like by the same amount, if that makes the output of your model more accurate. But like you have to determine that like experimentally. So like you can like try using kind of like several different sets of units and then see like which set of units give you the best like performance or accuracy, and then you can go with that set of units. All right, any more questions? All right, let's get into Python. I'm gonna pass it to Sudhanshu.
Can you see my screen?
Yes, we can see your screen. Okay.
Great. So yeah, now we're going to be transitioning this workshop into a more coding-based workshop. And sorry, give me 1 second. Yeah, we're going to be transitioning this into a more coding-based workshop. And the objective is basically to prepare you guys for the projects we have for you at the end of the quarter. So we're going to start today by giving you a brief introduction to Python. It's going to be pretty quick, but we have all the documentation available. And we're going to do this through a notebook. So I'm going to give you all a second to copy this link if you want to follow along. I will copy it to chat. And we're basically be working off this notebook. So I'm going to give you like 20 seconds to get to this link. So while you get there, the objective of this notebook is it's basically a really nice guide to serve as an introduction for Python. So there's a lot, what we've done is put together a lot of Python syntax, which is all really, really useful. And you're not going to need all of it for this workshop series, but it's still good to know nonetheless. And what we're going to be focusing on in today's lecture is the parts of Python that are, the link is sent me to a raw IP, YMB file. Yeah, like Jenson said, try opening it with Google Colab. So if you like sign into Drive, you'll get an option to open with Google Colab. Let us know if that doesn't work. Okay, someone's asking where do I find Google Colab? Let me.
Sudhanshu, you want to try opening it with the link?
Yeah, I'm going to do that. Yeah, exactly. So what should happen is you see something like this. You get this raw IPNB stuff, but then you say open with Google Collaboratory. So there should be an option right here at the top when you click the screen. Yeah, you could download the file as well, but as long as you're signed into Drive, it should work. Okay. Did anyone manage to get it open using just the link? Okay, it worked out. You signed in. Okay, I see. Okay, I see. Most of you seem to be getting it now. Okay, don't see option for collab. No, Google Colab definitely doesn't have to be downloaded. It's an online thing, so it's like Google Docs or Google Slides. Okay, but honestly, it's completely fine if you can't open it right now. The way I'd suggest doing it is simply saying Google Colab, clicking on this, and then you just load up the one you want. So I have Google Drive here. You'll see all your notebooks. I have a bunch of extra notebooks here, but yeah. But for now, you don't need it right now. We can just lecture off of this if you guys want to figure that out later. But does anyone have any other specific questions about any errors they're seeing or anything else? Okay. Okay, then let's get started. So just to quickly recap, we're going to be basically going over the parts of Python syntax that make it really different from other languages you may have coded in, like other languages you may have coded in, like stuff like C++ or Java. So we're going to be talking about these little nuances and little, like Professor Smallberg says, gotchas in Python. So there's some basic stuff, addition, multiplication, subtraction, modulo, exactly like you expect, plus, minus, asterisk, percentage. So the first thing that's different about Python is division. So you see here, there are two different types of division. You have regular division, which is decimal division, and you have integer division. And the difference is, if you just put one /, you get the decimal value as the output. So you get the actual 0.833. Now, if you're used to the whole C division and you want the truncated value, you put two /, and that gives you integer division. Another thing about Python, if you want to take 2 to the power 5, you put two asterisks in a row. So something like this. Now, variables, exactly like you expect. variable name equals value. Now, one thing we want to talk about is how Google Colab notebooks and notebooks in general deal with such variables. So say I run this statement. So what Google Colab has done? It's created this variable x and it's preserved that variable in its state. Now suppose I were to run this statement over here, x is equal to x plus 1, and I just want to print x. It prints out 4, exactly like you expect. But now, what if I were to run this statement again? What do you all think the value would be? Yep, exactly. So a lot of you guys are saying it's 5, and that's absolutely correct. So the thing to remember is that Google Colab preserves the state. So if you defined a variable 20 lines ago, it's still going to remember that. And it may seem silly that we're explaining it right now, but trust me, this is a source of a lot of bugs when you're trying to work with Google Colab notebooks. Oftentimes, you've just written like 100 different cells, and you're getting this bug again and again and again, and it turns out it's because you defined some variable a long time ago. So in that case, if you want to delete all the variables, what you do is you click on this area over here, and you click terminate session, and that'll clear up the state. Okay, so then another thing about Python, you define strings using either single quotes or double quotes. Either works just fine. That's just a Python thing. And it's also useful if you have like a single quote within a double quote to decide which one you want to use. Now, the way you print in Python is again really simple. It's just print parentheses value to be printed. So you say print num, print name, whatever you want. Now let's talk about some of the more fundamental data types in Python, data structures in Python, sorry. And the first and the easiest to use, I think, is lists. Lists are kind of analogous to linked lists in C++. But as you can see, they're way easier to implement. So you just literally need to put a square bracket, list out the values, and put another square bracket. And there you have your list. And the thing about lists in Python is that you can have all different kinds of data types within the same list. So you have a string, an integer, a float, anything is fine. You can have an entire object, a function, an image. You can put all sorts of things in a list. And you can also have nested lists. So one of the elements could be a list itself. So one of the most important use cases, of course, is accessing elements in a list or retrieving the information that you've stored. So the way we do that is by this indexing. So you open square brackets, put the index of the value you want, and close square brackets. And Python is a zero index. So the index 0 is the very first element. So in this case, the numbers of 0 gives you element 1. Numbers of 1 is the second element, and that happens to be this entire list that is contained in here. So like you see, we can have lists within lists within lists. And many times I want to access one particular value in this list. So suppose I were to run this cell right here. What do you think the output would be? Note that this is the list we're talking about, numbers. Okay, yeah, so that's absolutely right. We get the number 7 as the output. And the way we look at that is we say, this element is at index 3. So that corresponds to this. And within that, we look at element number 1, which is this. And within that, we look at element number 0, which is this. So that way we can access all the way down to this one particular number. Now, many times we don't want to access just one number. We want to access a whole subset or a range of values. And the way we do that is using this colon notation. So we specify the starting index, the ending index, and we put a colon in the middle. So this retrieves all the elements of my list between 1 and 4. And something to note is that the ending index is not inclusive. So we have index 1, index 2, and index 3, which are outputted. Index 4 is specified, but it's not included. So that's something to keep in mind. Another way to grab elements is like this. So we say, if we want all the elements, say from this point to the end, we just specify the starting index, put a colon, and leave the ending position blank. And that Python recognizes that to mean take all the elements that remain. So similarly for start, we just leave the first position blank and specify the ending index. And Python says, okay, I'll just take all the elements that come before 2 and return that. And of course, you can always reassign numbers and elements in the list the same way. So you access the element and give it a new value. So I'm going to pause here. Does anyone have any questions about what was just covered? Okay, cool. Let's get on with it then. So the next thing we're going to cover is dictionaries. And dictionaries are a really, really useful and very commonly used data type in Python. And what it does is it associates a key with a value. And what it says is that given this, so the way we access data is we say, given this key, what is the value associated with it? So you can imagine we could store all sorts of things. We could say, for a given student, I'm going to say, what is the name of the student? What is the student ID? What is the GPA of the student? Any value you want. And if you want to access it, you look it up in the dictionary. So in a real life example, a dictionary would say, what is the definition of banana? And it'll give you what the definition of banana is. So those of you who have coded in C++ before would recognize this as being similar to a map or a hash map. And it's fine if you don't know what that is. But that's basically what makes dictionaries a really fast way to store data and access data. And if you want to reassign the value, you simply say again, my dictionary at this value is going to be reassigned to this. So this is the key and this is the value. Another couple of useful functions, if you want to find out all the keys in the dictionary, you use this .keys function. And if you want all the items in your dictionary, you say .items. So I'm going to pause here really quick. Can you reassign values of keys? Yeah, that's exactly what we're doing here. So we say initially this value apple, sorry, this key apple was assigned the value 1, like the number 1 rather. Over here, we're reassigning it and saying now the value apple is associated with ONE1. Oh, sorry, can you reassign the name of key? Okay, I think I see what you mean. And so dictionaries won't work that way. So what you're going to have to do is delete that old value of the key and put in a new value. So yeah, there's no way to, so it's a key-centric approach. You need to work through these keys. You can't say, what is the key associated with this value? Can you hold multiple values in one key? No, so you can hold exactly one value, but that value could be a list or an array or a tuple or a function, whatever you want. So that's one way you could hold multiple values. But there's exactly one unit. Yeah, great. Okay, any other questions? Okay, cool. So comparison works like you'd expect, greater than, less than equal to, greater than equal to, double equal to. Oh, I see a question. How do you get the size of a list? Oh yeah, it's a good question. We should have probably covered that. It's just len of, I think we have a my list defined, right? Yep. So it's just the function len. And that returns the size of your list. Yeah, thanks for catching that. So then we have comparison operators, which are exactly like you expect: greater than, less than equal to, greater than equal to, double equal to. And one thing interesting about Python is that if you want a logical operation like and, you don't have a symbol for it. You literally just type out and or not, and that gives you the logical operation you're looking for. So in C++ or Java, you might be familiar with two ampersands or the two pipe signs, but it's way simpler here. You just literally type out and. Okay. And where do we use this? Well, we use them in if-else statements. So the way Python uses if-else is it says if condition followed by a colon and else followed by a colon. So this colon is very often used when you're defining a block of code. So in this case, since 2 is greater than 1, it says, well, print 2 greater than 1. So we have a problem here for you guys. Indentation is important, right? Yes, absolutely. So Python, as you can see here, doesn't use any curly brackets like we do in C++ or Java. And the way Python knows that a particular line belongs to a particular block is by indentation. But also note that if you don't indent, it'll probably give you a compile error. So it's pretty easy to catch these kind of mistakes. So another thing about Python, else if is denoted as elif. That's just a Python thing. So this is an else if statement, and we use it like we normally do: if, else if, else. So I see a question. So is not of 1 equals 2 the same as 1 not equals 2? Yep, that would be the same thing. Yep. Yeah, so we have a problem here. We've given a number 100 and we're given this block of statements. What do you all think the output is going to be for this? And I'll give you a second. Okay, yeah, absolutely. As you can see, the number 100 is greater than 0 and number 100 is less than 200. So it prints out the value C. So now let's talk about for loops. And of course, we're going to be using for loops literally all the time in machine learning in every application. So before we do that, we need to talk about this operation called in. What in does is it takes an element and tells you whether it's in your list. So in this case, 5, what this statement is asking, is 5 in my list? Yes, 5 is in my list, so it returns true. In this case, is apple in my list? It's not in my list, so it returns false. And this is really useful to define for loops, because the way we define a for loop is we say for an element in my list, print the element. So we can do we can pick out that element. Does in also work with dictionaries? Yep, absolutely. So the way in would work is it would check for the key. So if we have our dictionary apple, banana, orange, we'll say, is apple in my dictionary? It'll say yes. So it'll work with the keys. But if I say is 2 in my dictionary, it won't work. That information is not available to it. And yeah, so the way we do a for loop is we say for element in my list, and it goes over each of the elements in your list. So in this case, it takes the first element, prints it out, second element, prints it out, so on. We can do other fun stuff like this or like this. And the thing to note is what we call the element is completely arbitrary. So here I called it element, here I called it I, here I called it num. It's completely up to you. And every single time what it does is at every step, it picks out an element in the list and it goes over that list in the order that is presented. Okay, so does anyone have any questions about how for loop was defined just now? Yeah, because this is a novel way to define for loops. It's a lot different from how we do it in C++ or Java. Can we make it go backwards? Okay, that's a good question. I'm not sure how to do it with this notation. Of course, we can always do it with the index notation that we talk about later. But I believe the way you do it is you simply say like reverse of list. So let me try that out real quick. Okay, so reverse is not defined. My bad. I'm not 100% sure what the function is. Maybe Jenson can help me out here.
Oh, I think it's list dot reverse.
Okay, my bad. Yeah, so that is my bad. So it's instead of reverse of list, it's list dot reverse. That's a silly thing that you should keep in mind. So Python often, what is wrong with this?
Oh, that's weird.
Wait, what?
Oh, I think you have to reverse the list first and then loop through it. So you can't do it on the same line.
Huh. Oh, come on. Okay. Okay. Yeah, sorry about that mess up, guys. But yeah, essentially you need to reverse the list first. So this function over here is a mutator method. And it will completely reverse your list first. So the variable stored in your memory gets reversed. And then you say for I in that reverse list, print I. Okay, were there any other questions? Does a for loop always have to have the in part? Yeah, so the best way to define a for loop is with this in notation. We're also going to be talking about while loops, which don't have that. But yeah, so a for loop, the best way to define it is with this in operation. Let's see. Okay, so another really useful function is the range function. And this is a little more similar to how we do it in C++ or Java. What the range function gives us, so suppose we want to run this for loop 10 times. What we're going to say is, give me a range of 10. And this range function constructs an iteration over 0 through 9, or it gives you 10 numbers, and you can iterate through them. If you want a specific subset, like from 3 to 8, you say a range of 3 to 8. And suppose you want a step size, like you want to increment by 2 each time, you specify that in the last argument over here. Okay. Does anyone have any other questions? Did I miss anything? Okay. Yeah, I'm going to give you guys a sec if you have any other questions. Okay, cool. So another way to define loops is, of course, with while loops. And the way you do that is just while condition. So it's exactly like it's in any other programming language, and it's super simple. While end is less than or equal to 10, print the end, or do whatever you want to do. And it's just the condition over here. Can you slide? Oh, so I see I missed a question. Could you slice the list backwards? Yes. Let me show you how you could do that. Of course, doing it on the fly is always risky, but let's see. So this is my list, which is apparently reversed right now. And the way I'd slice backwards is I'd say, I think it's something like this. So minus 2. Okay, perfect. Yeah. So if you want to slice backwards, you put a negative sign in front of the index. So that says the last index would be, so this is the -1 minus 2th index, or the second last index over here. So the notation is essentially put a negative sign and it'll start counting backwards. So sorry for missing that question earlier, but that's how you slice backwards. Okay. Were there any other questions about anything to do with for loops or ranges or in or anything else? Okay, cool. So a really cool bit of syntax in Python is what we call list comprehension. And it's a method by which you can create a new list based off of an old list. So the way it does that is it says, it defines a rule. It says that for each element I in my old list, give me a new list where the element is I minus 1. So what that does, it takes each element in this old list, it subtracts 1 from it and gives you a new list. So this is a really compact, efficient way to define a new list. And it gives you 2 minus 1, 4 minus 1 is 3, 6 minus 1 is 5, 8 minus 1 is 7. So over here, what we've done is we've defined a new input array, which is a range from 0 to 5. And we're saying the output array is 2 to the power I. So what do you guys think the output is going to be here? Yeah, I'm going to give you like a few seconds. Okay. Okay, so I see a few different answers. And the right answer is, in fact, 1, 2, 4, 8, 16. And the way we get that is we say range gives me something between 0 and 5, but 5 is not included. So every time we define something in Python, the last index is not included. So this range outputs something which is 0, 1, 2, 3, 4, and we get 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. So if you see a few other different answers, I hope this clarifies it. But what we're basically doing is we're going over each of the elements in this list and doing 2 to the power I. Does range store numbers in an invisible list? Yeah, you could kind of think of it that way. So not to get too in depth, but what range basically returns is an iterable. So it's something that has no meaning unless you iterate over it. So if I were to say, range.append 5, that doesn't make any sense. There's no list that's stored internally, but it has all those values as soon as you iterate over them. So it's a little nuance to think about, but you should just think about it intuitively. The range gives you a range between 0 and 5. That's it. Yeah, like Jenson says, it stores in a range object, which is a iterable object. Any other? Can you explain for I in range 4, 10, 2? Yeah, 100%. So we have this over here. So for I in range 4, 10, 2, basically to stop and step size. So it says start at 4, end at 10, and every time I want to increment by 2. So it starts at 4, increments 2 gives you 6, increments 2 gives you 8. And note, this is not inclusive, so it won't give you the value 10. I hope that answers your question. Okay, great. So yeah, let's talk about how functions are defined in Python. And just like with everything in Python, it's super simple. You just say def, which is the keyword to define a function, and function name arguments. So this def tells Python that what we're defining next is a function. In this case, this function triple takes a value val and returns 3 times the value. So it triples it. So you see triple of 5 gives you 15. And you can also assign default values. And this is often useful when defining like big programs, because suppose somebody forgot to put one of the inputs in, you still want your program to run. So you have some kind of default value. So the way you do that is you specify what that default value is in the function argument. So real quick, what do you guys think the output of triple with no input is? Like, what is the output of this statement? Yeah, absolutely. So like some of you were saying, it takes the default value in this case because you've not passed anything in and returns 3 times that value. Now, a really useful functionality is what we call passing by keyword or keyword arguments. And what that essentially does is it says, it's all well and good to say triple of 5. That's going to work absolutely perfectly. And that's what we call a positional argument, because it depends on where the position is. But instead, we could specifically tell Python that val should be equal to 2. Now, it may not seem very useful here, but suppose we had 20 different arguments. Then in that case, we would keep track of the positions of all 20 of these things. And that's, well, a pain to try and keep a track of that. So in this case, we can specifically tell Python that val should have value 2, or let's say argument 2 should have value 5 or whatever. And this keeps stuff really neat. And it's a really useful thing, which we're going to be using a lot in machine learning libraries. So are there any other questions about how functions are defined or anything else? Okay, that's it then. So that is our intro to Python workshop. We have a worksheet here for you guys. If you want some extra problems that you want to check out, there's a lot of really cool applications to just test out your skills. Obviously, it's not required in any way, but it's a great bit of practice. And that's it. So next week, we're going to be talking about some data analysis. So we're going to build on stuff we just talked about, and we're going to be talking about these 2 libraries called NumPy and Pandas. And these are like 2 of the most commonly used libraries in all of computer science and machine learning and data science. So it's a really so they're really powerful and useful libraries. So definitely check that workshop out. And please fill out our feedback form. We're going to drop the link in the chat. And yeah, thanks a lot for coming. If anyone has any other questions, stick around. But that's it today.
Thank you.
Yep, you're welcome. Thank you for coming. Yep, we can definitely send the link to the slides again.
Quick question about the KNN. Do you have to recalculate the distance every single time?
Yeah, for each new data point, you basically have to recalculate the distance.
So if you had a pretty large data set, right, and your K value would be relatively large, that would be, I mean, pretty computationally heavy then, right?
Yeah, correct. That's why for most of like industry, like KNN is not commonly used, just because like it doesn't work well when you have a lot of data points.
Right, makes sense. Awesome, thank you.
And they're like probably like deep learning algorithms that like perform just as well and use a lot less time because we're KNN, there's no like one like training phase specifically.
Mm-hmm.
So we have to start with like a label data sets and then just classify like data points as we go. But like if you start with a relatively small training data set, like the size of your data set will increase just because you're classifying more data points as we go. So I guess in that sense, the accuracy will like improve like slowly over time as you have like a larger data set, but it's also going to take more like computing power and time. So if time is like an important factor for you, then and your data set is large, then KNN is definitely not ideal. But we're just covering it just because it's like intuitive and it's like I guess it does a similar thing to logistic regression, but then it's like a completely different approach. So that's why I want to cover it.
Yeah, but also I want to quickly point out that it's also useful if you have less data. So all the deep learning algorithms, you need lots and lots of data. So conversely speaking, if you have very less data, it's very difficult to train a huge algorithm. So KNNs might be a good option in that case.
Okay,
exactly.
So that would be the best use case. And so I guess follow up then, do you have to change your K value as you train more data?
Yes. I mean,
So,
slowly, I guess. I mean, if you start with like a really small data set, then you'll want to like increase K like kind of regularly. So if you have like 10 data points, then you'll start with K equals 3, and then you'll probably like increase to K equals 5 when you have like 25 data points, like that kind of thing.
So, but you don't know what the actual data point